Hey! Okay, okay. Super. Uh, Hello, dobar večer, good Abend. My name is Sven Maričić. I'm here from Rijeka, and I will present you some of the particles of my life, what actually I've been doing since I have decided to do some things from my childhood. And I just want to be sure that you're all awake. Is someone sleeping? Test. Yeah, you are sleeping. You're not sleeping. Come on. So basically, I will show you. I will tell you something about me. Who am I? What's something about my process? Additive manufacturing, biotechnology intro, segmentation, case studies, all that in just 48 slides. And I have 3 jokes. I already told you one of fitness or something. Okay. First of all, I would like to thank you all of my partners, sponsors who were very, very nice to me from 2007 when I decided to sign for my PhD studies. Thank you very much, and God bless you, Cyberpunk bless you, someone bless you. Okay, since my childhood, I was always dreaming about being big one, you know, scientific lab things and so on, to be able to speak late night in English in front of 200 people. That was already. Night, moon, the rocket, and the sun is here. Now, at the present moment, I'm head of a lab and I'm running one small project, and of course I'm hanging around with some nice people who are actually my idols in some scientific way, you know. But everyone can do that, so I'm the example of that. Today, as I told you before, I'm working as a head of one laboratory here in Rijeka. My second love is also 3D printing, 3D modeling, CAD/CAM, and some other letters that you don't understand, I suppose. I'm very, very happy that we are here tonight because 5 years ago, people from Rijeka were the very first one who actually succeed to apply 3D printer in surgery, and I will speak to you about later. Just a few things about how stuff works actually. Our focus is 3D printing, but 3D printing is a main topic. Before that, I would like to say something about people and connections between people and Facebook stuff and so on. It's very popular. Biotechnology includes biology plus technology plus management and marketing, because if you are not good as a marketing promoter or something like that, come on, it's funny. Okay, it's not. Ballet, yes. You will not be able to sign for grants and you will not have money to achieve that. Future of biotechnology, as we have seen tonight, it was very, very hard. 1941 biotechnology was the first invented as a word, and 2000x6 I think we'll have biomarketing technology. Of course, when you're dealing with different projects, you can always go alone, and I prefer to call that way by bicycle. And of course, if you are running bicycle, you can go one step and one step. Of course, you can then take a car. If it's a good car, you will be faster, but still, if you are not able to do 2 things in the same moment, that's no good. I prefer to go by bus. Here's one bus. So, speaking of bus, in my small team, during the bus ride, we have students, we have doctors of medicine, we have engineers, and maybe we can have you as well. Feel free to join to some. Yes. Today, it's not a problem to print heart or kidney or just imagine whatever you want. It's a problem to solve some other things. To print quality in small amount of time and to be just in time, as people from Japan would say. So, first of all is model digitization, computer editing, 3D print, and quality measurement control. If everything works, then we have similar situation. Of course, the approach is following. We have CT and MRI scanning, then CAD and some computer things are coming out. Segmentation, CAD-CAM projecting, where we are actually measuring, projecting CAM parts, machining, and so on. We have AM and ART. AM stands for additive manufacturing. That whole universe of rapid prototyping now includes, actually this includes rapid prototyping, or RT is rapid tooling. The last result presentation. Okay, segmentation actually means some mathematical stuff, numbers and so on, and since it's very late I will not do into numbers, but it's divides the essential from irrelevant area of image. This is a little bit of math, I'm very sorry for that. In this matrix you will see the results on the following slide. This is a forehead bone, this is a background plus noise, and this is our brain. Obviously this person was not thinking at all. or maybe it is, I don't know, I'm not so sure now. This was taken here in Rijeka's hospital, and it shows some examples about threshold segmentation and edge-based segmentation. I think this is the last slide of math. And now we have some 3D segmentation result. This is our forehead, this is sinus and bone, of course with some numbers. But you know what? I have some 3D print here with me, and I'm totally sure that you will return this 4 piece of sinuses. Okay? Okay, cool. Here, one for you. One for you. Please just return me that. One for you. One for you. Okay, so this 3D model actually is printed out and you will have it in your hands in a matter of minutes. This is a little bit of cross-section and rotated cross-section. And Mr. before me was very detailed, explained everything, so I will not say much. Calibration is also one of the important things, because if your device is not calibrated, then your results will be poor. Okay, here's the best part, some zeros and numbers. Professional devices can be as much as €500,000 till almost €1 million of money. And this is one of the interesting devices, Object Eden, and you can see that we can now print with great precision. This part is printed in 3DP technology. Okay, in Rijeka 2008, imagine this ship was somewhere else, but we were not sleeping, 2008. Case study was male, 30 years old, patient with maxillofacial defect. The main problem was, it was huge hole here. So, and it was, for me, as I'm coming from Faculty of Engineering, it was, you know, sometime in your life you can understand people who are saying that it's not all about money. And I think it was my first steps in that, towards that. Yeah, it was very tough. This was the model. I made first CAD-CAM model, then doctors made this surgical procedure as was 2008. And the last one was my solution. It was during my PhD studies. And during the operation, everything went very well. So this was the very best moment when my teacher said, Sven, I think we have good results. And I said, thank you God, 3D print, and Linux, XP, Windows. So you can basically see the results. You cannot distinguish now this person in real life, and I'm very, very satisfied and very grateful for that. And I was, of course, 5 years younger than now. Okay, some numbers. Material savings, 30% less. Surgical operation time, it was 40%. Imagine that. Instead of 2 hours and 30 minutes, whole operation went in something like 1 hour and 40 minutes, something like that. Okay, after that model, we have in Rijeka, we are preparing one model for surgical operations. Actually, surgeons can be able to not practice, but to learn on that model before operation. And we are very proud of this model because our competition made model 3 times thicker than our model, and 10 times that model is expensive. Ours is 10 times cheaper. Imagine that. 2 years of work and not going out, social life. I already log out of the Facebook. Basically, it will be very good in next year or year and a half. This model will be on the market. Now we are making final design and final solutions for production. And it's made here in Rijeka. Next slide will show us how actually we look like in the middle of our skull. So next time when someone says that you don't have anything in your head, it's partially true actually. Okay, this one shows us some engineering approach. How can we build this? So this is a tool path, and this is a model after the operation, I think 2 or 3. Okay, a little bit of details. And of course, maybe you know these guys. They're playing here in Rijeka. Their first Croatian band. They're 3D scanned last year. We made one exhibition, and I was very happy. Everything went very good. And now we have 3D models of their faces. Look this. Of course, it's artistic point of view. We scanned them with laser, entry-level laser 3D scan, and then I made some adjustments. I'm hoping that you can see well this. Can you see it? Okay. Of course, world is going around, and we are also making some 3D printers like others. And this is one project that I'm running with my students. Actually, it was 2 years ago. And I will show you some pictures of models. We are now thinking how will the final model looks like. And here is one of the solution that I think it will be the best so far. So in next few years, I think in Rijeka we'll have originally 3D printer. Okay, and this is hopefully final design. What do you think? Sleeping, sleeping. Okay, cool, thank you. Okay. Okay, I have 5 minutes more. This was a sex. Sex sells everything. No sex for you today. Successful people, successful society. It's too late for me, I'm sorry. Successful society, as we want to declare that we are belong to technologically, I don't know what, we are always forgetting that we are just people, and that all we want in our lives are actually, we want nice childhood. Remember me with the bike and that rockets and Jules Verne stuff. But we humans actually can say something is hurting me and something is bad with my leg, foot, I don't know. But when we are speaking about successful society, we are always say that animals are also part of our society. This is Ka. Story is not successful, I'm sorry to say that, partially successful. And the Ska is very brave young dog. Unfortunately, orphan dog. But okay, there are lots of young children in orphanage these days. So this is one dog more or less. And the story with Ska is interesting because I made several suggestions about design for the dog. And this was the very first one, and I'm very proud of that, and of course, it's almost like my baby. And this is almost the final design, influenced by Mr. Pistorius or something like that. I was reading lots of articles. Federico, I don't know what's his name. And I think if we want to be part of that successful society, we should take actually our thoughts and join to good ideas. Maybe it will be good that we can start here in Rijeka one center for, I don't know what, CAD/CAM modeling for orphanage dogs, CAD/CAM center, 3D printing center for, I don't know. Maybe we can make clusters of open source 3D printers. It's not funny anymore. Now it's a little bit about what we are actually made of. So, I'm wishing that Ska will also have opportunity for nice childhood. And I'm crossing my fingers. I'll do the best. Thank you very much. Please, just don't forget to return my parts. It will be 2 questions. 3! Oh my goodness. Can I see 4 gentlemen in the second row? Is it possible? I will repeat. Is it possible to make? No, it's not. Is it possible to make 3 electrical components? No. So far it's not. Is it? Almost. Yeah, we are near. Yes. Next question. Okay, about printing organs, we are almost close. Actually, there are some steps toward to that. We are now able to printing scaffolds to support, for instance, jaw but organs so far, I think, no, I'm sorry. Oh, the estimate time of 50 years. No, I'm just kidding. I think next 20 to 30 years it will be for liver. Yeah, maybe 50. Yeah, liver is NP heart problem. It's just my opinion. Ask me something. No, I'm just kidding. Okay, the last one, please. No, okay. So
actually, I thought that is it possible? So I thought that it will be possible to actually print like bone marrow directly into the body, like merging it with well, the body you already have. So this is how far away is this?
I'm printing in with SLM. SLM stands for selective laser melting, and there is one great problem with that, because if you have device who is printing with titanium alloys, it must be certified. You can print just with biotech things. You cannot print parts for your car, you know. It's very expensive, so there are not lots of machines out now. It costs, that SLM machine costs around 600,000 euros or something like that. It's very expensive. And I think our best solution will be join our things together, our heads, everything. And I think that in that case we have chance to start that part of R&D, research and development. Thank you. Okay, thank you very much. Woo!